All right, 12.4 deals with probability of compound events. So a compound event is something that can happen separately or at the same time. This other concept we're going to talk about today is mutually exclusive events. So they're two events that cannot happen at the same time at all. So the key for today is we're going to use this probability of compound events formula where it says if A and B are two events, then the probability of one or the other happening is the probability of A plus the probability of B. So this is what we've gone over so far. When you have an OR problem, you add. The new part to this, though, is we have to subtract off the probability that both events occur. Okay, so what's the probability that they both could occur at the same time? And example one is a perfect one for that. So you have a card randomly selected from a deck. And what's the probability that it is a king? So this would be event A. Okay, I like to label them as I go through. So the probability of event A, okay, the probability of getting a king. Well, there's 4 kings in a deck of cards. There's 52 cards. So it'd be 4 out of 52. Or the probability of getting a spade. So we're looking for the probability of B. So in a deck of cards, there are 13 spades, still 52 cards. Okay, so we want the probability of A or B happening. Now, this formula has this new part on the end where it's the probability that both A and B happen. So now we have to start asking ourselves, is there any card in the deck that is both a king and a spade? And if there is, we have to subtract that off. So in a deck of cards, there's only one king of spades out of 52, but there is a king of spades. So we have to account for that. Plugging in, we now have everything into our formula except the A or B, which is what we want. So we can go ahead and simplify these fractions. They all have common denominators, so we can go ahead and add them up and simplify. So it's going to end up being 16 over 52. Simplifying that fraction, it's going to give me 4/13. So that would be the probability of getting a spade or a king. For number 2, go through the same scenario. Go ahead and label them. So probability of a 6. So here's my A. So the probability, not rolling, of getting a 6 from a deck of cards is going to be 4 out of 52. And then event B is a face card. So in a deck of cards, there are 3 face cards per suit. There's 4 suits, so there's 12 face cards. There's no 6s that are also face cards, so we do not have a probability of A or B on the end. So up here, we had a king that is a spade. Down here, there's no 6s that are also face cards, so we don't even have to worry about subtracting that off on the end. You go ahead and simplify your fraction. You're going to get 16/52. And end up being 4/13. So the same deal with what we got for number 1. Number 3, you got a 6-sided die is rolled. It's from the other day. You can go ahead and do that one. Okay, so the types that I worry about a little bit, and it's not really worrying, but they're a little different, are problems like example 4. So it's real important that you go through and label all these events. So you have juniors that took a French class. This would be event A. Okay, so the probability of taking a French class is 6 out of 15. 11 out of 15 took a math class. That's your probability of B. And it says 14 out of 15 took French or math. So this is A or B. So it's a little different from the previous one because we are plugging in for our left-hand side, the A or B. And this time, they are asking you to solve for the probability that both are occurring. Okay, so really, when you know the formula, it's not that bad. You just have to use your simple algebra 1 skills. So I plugged in for the probability of A and B happening. I have the probability of A, probability of B. You need to solve for A and B. So fractions, left-hand side, you can't do a thing. Right-hand side, you get 17/15. Got to get the probability of A and B by itself. So go ahead and subtract the 17 over. It's going to give me negative 3/15 equals negative P and B. Again, we can't have a negative, so you divide each side by a negative, and it's going to give me a positive 3/15. And then you have to simplify the 3/15 by dividing top and bottom by 3. Doing that, it's going to give us 1/5 as our probability. Number 5 and 7 are the same exact way. You just have to go through and label them. Okay, so you have probability A, probability B, and then plugging into our formula that we've been using today. Last thing we're going to talk about today is the complementary, or the complement of an event. So probabilities always add up to 100%. Okay, so if you want to figure out, like if they tell you what the probability of an event occurring is, you want to know the probability that it doesn't occur, you just do 1 minus or 100% minus. So for example, on number A, they say the probability of event A occurring is 0.35. This right here is the probability that it does not occur. Okay, so that apostrophe just means it does not happen. So to find it, you have your formula up here. We just flat out plug in. So you got the probability of A not happening equals 1 minus the probability of A. So plugging in, that's what we want. You got 1 minus 0.35. So the probability of event A not happening is 0.65. And you could do the same thing down there. So you figure out what the probability of event occurring is, then you do 1 minus, because they add up to 100%, like it occurring or not occurring, it's 100%. And you go from there.